Now I'd like to show you how you go about doing story problems, or I call them real life situations, using systems of equations. So first we're going to follow a 5-step plan. No matter what, you should always read your problem carefully. After you read your problem, you should go back and identify the variables. To identify the variables, that usually comes from the question at the end. Next, you should write your equation. So by reading carefully, that means you're going to go back and you're going to literally translate your words to math symbols. After you have your equations, then you will go ahead and solve them. Some people think they are then done. The last and final step is check for reasonableness. Make sure your answers make sense to what is asked. If it is asked, how quickly can I walk to the grocery store? And I say my speed to the grocery store from walking was 50 miles per hour. That is not reasonable. There's no way someone can walk at 50 miles per hour. So you must always make sure what you get for an answer makes sense to the situation. So let's try this. If you have 8 pens and 7 pencils, they cost $3.37. 5 pens and 11 pencils cost $3.10. How much does each pen and pencil cost? So there I read it. And to show that you read something carefully, you're going to have to underline or highlight. So I'm going to do that as I go back. First, it said, how much does a pen and a pencil cost? So right there, I see I've got the pen, its cost, and the pencil's cost. I'm going to call the pen P, and I'm going to call the pencil Y. Now when I go back and I read 8 pens, so this becomes 8P. So I'm just going to translate on top because pens is P. And means to plus in math. 7 pencils. Pencils was Y. Cost is my verb. All verbs get an equal sign. And then I have 3.37. So right there, I've translated the words to math symbols. And I get 8P plus 7Y equals 3.37. Now I'm going to do the same with the second sentence. And I see 5 pens, so that is 5P plus 11 pencils is Y. Cost is my verb, 3.10. So I get 5P plus 11Y equals 3.10. So there's my system of equations. I've identified the variables. I show I've read carefully. I translated to equations, and now I need to solve. So I'm going to solve by linear combination. I'm going to multiply the top one by 5 and the bottom one by a -8. Then these will be 40p and a -40p, and they'll eliminate. So I get 40p plus 35p equals 1685. negative 40p minus 88y equals negative 2480. Now when I add them, my p's should drop. 35y plus negative 88y is negative 53y. 1685 plus negative 2480 is negative 795. Divide by negative 53, and I get y equals 0.19. Y is the pencil's cost, so that would be $0.19, or we could say 19 cents. So I'm going to jot that down. The pencil cost $0.19. And the pen's costs, so I'm going to take this and I'm going to substitute it in here. So I get 8p plus 7 times 0.19 for y equals 3.37. That's HP plus 1.05 equals 3.37. Subtract 1.05. HP equals 2.32. Divide by 8. I get P equals 0.29. So this would be $0.29 or 29 cents. So a pen's cost is 29 cents. And there, I've made sense of it because it makes sense that a pencil would cost less than a pen, and a pencil costing 19 cents, that makes sense. So I've done all 5 steps. Okay, now let's try another one. This time we've got Anne paddling her canoe 15 miles downstream in 2 hours, and the return trip upstream takes 3 times as long. What is the rate of the current? Okay, so when we have one of these current problems, there's some information that we need to understand. We have 2 kinds of currents. We either have water or we have wind. And by the current, it's the speed of the current. So I'm always going to call my current speed W, since it is either water or wind. And then I'm going to always have the rate of a vehicle. And I'm going to call that R. That would be the speed of the vehicle. In this case, I have a canoe. We could have a boat. We could have a car. We could have a jet. We could have a person walking. We could have a person running. We could have a bike. All different kinds of vehicles that have a speed. And anytime I go with the current, if I'm going with the water or with the wind, I should be going faster. So that means I would add these two, the vehicle plus the current. If I'm going against the current, I would subtract them because it should slow me down. Another name for with the current, like with the wind, against the wind. If it's water, with the water would be upstream. Excuse me, with the water would be downstream. Against the water would be upstream. Sometimes with the winds, when it's going with the wind, they might call that a headwind. No, that is wrong. With would be a tailwind, that it pushes you at your tail. Against would be your headwind. It pushes at your head. So with the current is like tailwind, downstream, that means R plus W. Against the current means upstream, headwind, R minus W, every single time. So we're going to come back here now, and I was asked for the rate of the current, so I'm going to underline that. So that means R equals the rate of the vehicle, which is the canoe, and W equals the water's rate. So I see Anne can paddle her canoe 15 miles downstream in 2 hours. So her speed would be measured in miles per hour. So I always am going to start with my fraction, miles per hour. Then you multiply your fraction by your denominator. So if I multiply it by hours, these would eliminate, and I get just miles. This is where rate times time equals distance comes from. And this creates a way for me to organize what is happening. And I saw downstream. 15 miles would be the miles. 2 hours would be the hours. Downstream, as we noticed over here, downstream is R plus W. Then the next one says, on the return trip upstream. So I've got upstream. So I automatically know that's going to be R minus W. Upstream, R minus W. It took her 3 times as long. So if downstream was 2 hours, this is 3 times 2, or 6 hours. And if she went back the full way, it is still 15 miles back. Now we just follow this. Miles per hour, which is R plus W, times 2, so that whole quantity times 2, equals 15. And this one would be 6 times R minus W equals 15. Now, I can either distribute those through and then solve, or since I know I'm going to have to get my variables alone, because here I'd have a positive W and a negative W. If I multiply all of this by a half and this side by a half, I get R plus W equals 15 halves, which is 7.5. If I multiply this by 1/6 and this by 1/6, I get R minus W equals 2.5. Now I'm ready to add those two equations. R plus R is 2R. W plus negative W is gone. 7.5 plus 2.5 is 10. So I divide by 2, and R equals 5. Go back up here. R was the rate of the canoe. 5 miles per hour is the speed of the canoe. But I was asked for the rate of the current. So I'm going to take that 5 and plug it back into this top equation. 5 plus W equals 7.5. Subtract 5 W equals 2.5. 2.5 miles per hour is the speed of the water. To show that it makes sense, I'm going to write the sentence. The water flows at 2.5 miles per hour. And then I just have one more. A grocer mixed nuts worth $4 per kilogram with raisins worth $3.25 per kilogram to make 15 kilograms of a mixture worth $360 per kilogram. How many kilograms of each nuts and raisins are in the mix? So again, how many kilograms of each nuts and raisins? So I have nuts and raisins. So I'm going to call N the kilograms of nuts and R the kilograms of raisins. So then when I read this, nuts worth, that's my verb, $4 per kilogram. So again, that per is a fraction, so that gives me dollars per kilogram. Multiplied by the denominator gives me the numerator. And this is a way I can start to organize my table. So the grocer mixed nuts worth $4 per kilogram. With raisins, $3.25 per kilogram, to make a mixture. So when I'm mixing things, I'm taking the first item plus the second item to get the mixture. So I have a mixture of 15 kilograms, so kilogram is the mixture, worth $3.60 per kilogram, 3.60. Kilograms of nuts was N, kilograms of raisins was R, and this says to multiply, so this is 4 times N, 3.25 times R, and 3.60 times 15 gives me 54. So in this case, my equations are located right here and right here. So I have N plus R equals 15. 4N plus 3.25R equals 54. And I'm going to do substitution. If I solve this one for nuts, I would get N equals 15 minus R. I'm going to put that in the N spot. So I get 4 times 15 minus R plus 3.25R equals 54. 60 minus 4R plus 3.25R equals 54. 60 minus 0.75R equals 54. Subtract the 60. Negative 0.75R equals negative 6. Divide by negative 0.75. And I get R equals 8. R is 8. R is 8. 8 kilograms of raisins. So then N plus 8 equals 15. Subtract 8. N equals 7. And 7 kilograms of nuts make the mixture. That sounds reasonable.